Okay, so today we're going to be talking about refraction. Refraction is just the change in direction of light due to the change in speed as it passes from one medium to the next. So I emailed everybody these notes, 13 notes, and I'm just going to break down those notes, and then I'll go through the practice problems. So got an example here, and this is written in your notes, but right here we're showing two different mediums. I've labeled this one as air and this one as water because that's an example that we can all kind of see and we have seen before, and it's pretty similar to the diffraction of water video that I sent you. So what this is showing, we have our medium 1 above this plane right here, this x-axis, and then medium 2 below it. So the air above, water below. And then we call the normal is a perpendicular plane perpendicular to the medium. Okay, our angle of incidence, which is the light coming in, is here, and then our angle of refraction is right here. Okay. So as light is slowed down as it enters a medium, it's going to bend towards the normal. So in this case, as light hit the water, that light slowed down because this medium was more dense than the water is more dense than the air. So it's going to bend that light towards the normal, which again was that perpendicular plane in respect to the medium. Okay, if it speeds up, so if this medium is going to be less dense, if it speeds up, that light is going to be bent away from the normal. Okay, and the amount of bending that we represent that with the letter N. And N stands for index of refraction. So our variable N. And the index of refraction is a ratio of the speed of the light in a vacuum to the speed of light in another medium. Okay. Index of refraction. It's going to be that ratio of the speed of light in a vacuum, which is C, and then speed of light in another medium, which is V. So this is, we all know that is speed of light. And then that V is going to be the speed of light in another medium. So again, with all these problems, we're just looking at how is light bent when it passes from one medium to the next. Okay, so because light travels fastest in a vacuum, the index of refraction for any other medium is always going to be greater than 1, and air is really, really close to 1. Erase that. So we will use index of refraction for air. For air, that's going to be 1.00. And again, that's for air. And the angle of refraction it's going to depend on the index of refraction of the two media that the light's passing between. So we'll label those two media as N1 and N2, index of refraction for media 1, index of refraction for media 2. So we use the formula N1 sine theta 1, which is our index of refraction, equals N2 sine theta 2. So this is angle of incidence, angle of refraction. thing. All right. And then we do have one special case. We're not going to deal with this too much, but I do just want to cover it very quickly. We have a special case where when light passes through from a more dense medium to a less dense, so for more dense to less dense. So this tells us right there, from more dense to less dense, the light is going to be bent away from the normal because it's going from more dense to less dense. If you look back to that diagram that I just gave you. If, when it does this, goes from more dense to less dense, and it makes an angle of 90 degrees with the normal. So here we have our medium, we'll just say our medium 1, or medium 2. Here's our normal. We just say that. All right. So we're going more dense to less dense. Let's just say we were going from, and it doesn't matter, I guess, what the examples would be. So more dense to less dense. If we're here, it's going to be bent away from the normal. And anytime it is bent away from the normal at 90 degrees to the normal, we call that a critical angle. It's going to be labeled. It's our critical angle. And when this happens, there is no refraction at all. All the light is going to be reflected back into the object. So that's a really special case. We're not going to deal with that too much, but anytime a light goes from more dense to less dense, and that angle of refraction here, angle of refraction, if it's 90 degrees to the normal, all that light's going to get reflected back into the object. Okay? So in this case, it'd be N1 sine critical angle equals N2 sine 90 degrees, because we've got our 90 degree angle right there. Okay? So I'm going to go ahead and work through a couple practice problems. I will work through example 6, 6 and 7. Work through example 6 and 7 on page 178, and I'll do that in the next video.